Welcome to the next segment of High School Geometry with Netz and Weichel. I am Mrs. Netz.
And I am Mrs. Weichel.
Today we are covering 2.2 translations. What we are doing, by the end of the lesson, you will be able to use geometric descriptions of translations to transform figures and to predict the effect of the given figure. So, why we are doing this? It is important to understand that a two-dimensional figure is similar to another if the second can be obtained from the first by a translation. You'll know that you know how to do this if, when given two similar two-dimensional figures, you can describe the translation that exhibits the similarity between them.
All right, let's go ahead and get started. So a translation is when you shift all points in the same direction and the same distance, like a slide. So please fill in shifting all points in the same direction and the same distance.
You can think of a translation as a push or a shove. So if you go to move a piece of furniture in your house and you sit down on the floor and you push it with your feet because it's so heavy, you are actually translating it across the room.
Next, vocabulary word. Translation, by the way, is a vocabulary word that you need to know. The next one that you need to know is a vector. A vector represents magnitude and direction. So magnitude is the how far you're going, and the direction is which way are you going to go in. A vector always has an initial point and a terminal point. In this graph right here, this weird looking arrow shape, that is actually a vector. So I would draw or add in lots of notes on your paper right now about this. Students tend to struggle with a problem like that. That right there is a vector.
A couple of vocabulary words you just had: the word vector, the word magnitude, initial point, and terminal point. These are all parts of the vector that you need to know. The initial point is where the vector starts.
So this is your start right here. Start is going to be your initial point.
Okay. The terminal point is where the arrow is on the vector. That's where it ends.
So this point right here is where it ends.
Okay. Your magnitude would can almost be kind of thought of as the slope or the rise and run. So for example, in this one, it would be that we are going to go down 3 and over 5. Now,
So this translation is saying we are going to go down 3 and right 5.
now the direction is we are reading this particular vector from left to right. There are times when you will read a vector going from right to left. It just really
depends on which way
depends
the arrow is facing.
where your terminal point and your end point are.
So we could take this triangle and we would move it, slide it, shift it, shove it, however you want to think of it. You would move it how it's describing here. You'd go down 1, 2, 3, and you would go right 1, 2, 3, 4, and 5.
Now notice what she is doing. She's starting at point A, and then she is doing what the vector told her to do, down 3 over 5, and making a new point A, or what we would call A prime.
So right here, if I take B and I go down 3 and right 5, B prime is ending up right there. And then C, we would go 1, 2, 3, and 1, 2, down 3, 1, 2, 3, and right 1, 2, 3, 4, and 5. And then with our straight edge, we can connect our sides, making our new image. So we have our pre-image,
which is triangle ABC,
and our prime notated, oops, where did my C prime go? C prime. We have triangle A prime, B prime, C prime is our image. So again, when you have, so A went to A prime. This right here, please add this note. The little apostrophe is called prime notation. And we use that to show that we moved A and the image became A prime. If you were to move A prime would become A prime prime or A double prime. And if a double prime moves, it becomes a double prime prime or triple prime and so on. So you keep moving it to show the sequence in which you are moving it. Okay, so when we did this translation, you can see that the two triangles look very similar because you're shoving or pushing or sliding all the points in the same exact way. So therefore, we have some preserved and not preserved features when we are dealing with translations. The shape will not change, so therefore it is preserved. Your side lengths, however long they are in the pre-image, will not change. They will be the same length when you are done with your translation. Also, the angle measurements are not going to change. Whatever degree you are starting with, you will finish with. The orientation, what we're referring to with orientation, if I go to A and I say this is A, B, C, I'm going around the triangle in a counterclockwise fashion. If I go to my new image, A prime, B prime, C prime, if I go in the same direction around the triangle, it's the same order of letters. So that's what we talk about with orientation. The only thing that has changed or not preserved is where it is. The position of the triangle has moved to a new location. How do you know when to do a translation? You can be verbally told to shift right 6 and down 5, or translate right 6 down 5. It'll actually say what to do. Please fill that in. Mapping rule. A mapping rule, you want to think of that just like your basic input-output you did in algebra. You are going to have a pre-image. You're going to have your x, y coordinates, and whatever x is in the pre-image, you would add or subtract to it depending on if you are going right or left. If you think about a coordinate plane, going to the right would be a positive move. So going right means you are adding to your x coordinates. If you are going up or down, that's going to be how your y coordinates are changing. So if you are going down, that means you're going negative, and then you put the how much. So again, that whole magnitude and direction. Magnitude is the number. The plus and minus is telling you the direction in which you are moving in. Notation. So we have a capital T. Please make sure you include that it is a capital T for translation, and then a subscript. A subscript is going to look literally the opposite of what an exponent would look like. Instead of writing it in the upper corner, you're writing it in the lower corner. And you're just writing, again, the direction. Before the comma is always an X, so before the comma is going to be your left and right shift. After the comma is where Y typically is, so after the comma is going to be your Y shift. And then lastly, vector component form is specific to translations. You will only see this when we are talking about translations. It is the same thing as the notation in that it's just the number. You need to remember that before the comma is your x coordinate, so therefore before the comma in a vector form is your x move. After the comma is going to be your y move. The other thing that you need to make sure you add, these are not parentheses, they are angle brackets. They're like pointed parentheses. So that's huge. If you were to say you're going to translate and then you put an ordered pair with parentheses, you will lose points. If you are talking about a vector, you need to make sure you are using those angle brackets around it. They are pointed.
All right, let's go ahead and turn the page and let's practice a translation.
So on the back, you guys have the SLID written for you. You need to go ahead and pause the video maybe and fill in the ordered pairs that you're going to be using for your pre-image, and then go ahead and graph that pre-image on your graph, please. Okay, so your SLID quadrilateral should be graphed by now. We are going to go ahead and we are going to slide. I'm giving you a verbal description up here. You're going to slide it left 1 and down 8. So I am going to zoom this in so I can see better.
So what you're going to do is you're going to take every single point on SLID, and you are going to go down, sorry, left 1, and then down 8. Left 1, down 8.
So S is going to go left 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So right here is where we're going to put S prime. D is going to go 1 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8 down. And we would say that is D prime. Same for I. Notice as I'm doing this, I am not treating it as the shape translating. It is the individual vertices that are actually translating. Please remember that in this whole unit. When you perform a transformation, you have to look at the individual points that are moving, not the shape as a whole. So 1 to the left for I, 1, 2, 3, 4, 5, 6, 7, 8. Right there is going to be our I prime. And then lastly, the same for L. 1 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8. So right there is going to be our L prime. So as I do this, you can see that if I slide this whole thing, 2, 3, 4, 5, 6, 7, 8. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8. Okay, there we go. You can see that when I move the individual shapes, you can see, I wanted you to see the idea of congruence is there. That congruent idea that the shapes are congruent by their sides being the same length, the angles are the same, the points are now in the same location by them all moving in the same exact direction and distance.
Now, when you go to your table, for those of you that are more algebraically minded and you like doing the math rather than the graphing, you can find the coordinates also by doing the math. So if you remember, we said that it was left 1, down 8. So left, moving left on the graph will always be subtraction, and moving right will always be addition. Moving down will always be subtraction, and moving up will always be addition. So what you can do is you can take all of your x values from your pre-image and subtract 1. So -9 minus 1 is -10. -2 minus 1 is -3. -1 minus 1 is -2. And -7 minus 8, -7 minus 1 is -8.
Okay, I'm sorry. I was listening to Miss Nets. I'm not looking at what I'm writing. So you're just doing the x values right now.
Yes.
Okay. I'm with you now. I apologize, everybody.
So -10.
-2 minus 1, here's the -3.
Yep.
Okay. -1 minus 1, -7 minus 1.
So now I'm going to go ahead and do my y values by subtracting 8. So 4 minus 8 is -4. 2 minus 8 is -6. 5 minus 8 is -3. And 7 minus 8 is -1.
So you can see by using the rule, you get these 4 coordinates. Those are the same 4 coordinates that I got initially by just counting on the graph. So it is really up to you with your comfort level what you prefer. The vector is, again, you can look at it from just the rule. You're going to take out the x and the y and put angle brackets around the numbers though. So we have angle bracket -1, comma, -8, angle bracket. So that is our vector. And then lastly, the notation is going to be t sub the x and y shift. So t and then subscript -1, -8. -1. There we go. So we're going to go ahead and ask you guys now to pause the video and do the other 2 translations for us. You have one that's going to take, we're going to go back to the pre-image so that we say on the graph, so please don't move the prime notation. We want to move just SLID original, okay? You're going to take it right 9 down 11, so that's this one. And then the last one, you're going to take the pre-image SLID and you're going to go right 10 up 2. So go ahead and pause the video and give it a try. Okay, hopefully this is what you guys came up with. You can see for the right 9 down 11, you should have ended up with S prime at 0, -7, L prime at 7, -9, then 8, -6, then 2, -4, with a rule of x plus 9, y minus 11, a vector notation of 9, -11 in angle brackets, and then T, capital T subscript 9, -11 for your notation. For the last one, the right 10 up 2, you should have gotten 1, 6, 8, 4, 9, 7, and 3, 9 using the rule x plus 10, y plus 2 with a vector notation of 10, 2 in angle brackets and a notation of capital T subscript 10, 2.
Not so bad.
Not so bad. So hopefully you guys feel confident in translating a figure and in describing a translation in the different ways, meaning can you write the vector, can you write the rule, can you describe the notation? If we were to ask you to perform a translation in any of one of those fashions, would you be able to confidently perform it?
I think we could.
All right, as always, if you have any questions, please send us a message or reach out to your teacher. It's been real.
Hey, Mrs. Weichel.
Hey, what, Miss Max?
What do people who whine a lot and 3 points have in common?
What?
They're both co-planers.
Ah ha ha. Thank you for joining us. We will see you again in 2.3.
Bye.